Okay, we're going to go through this learning check from the end of section 13.3 about concentration units. In class, I gave you the answers, so I'm going to go ahead and erase these, and we'll do molality first and then mole fraction. So this is a question that's not uncommon as far as the way it's set up, where we have a few things we're trying to calculate, some information, and we need to know how to take the information given, know what we're looking for, and then figure out how to get there. So let's do molality first. Remember, this is moles of solute over kilograms of solvent. We know we have 18 molar sulfuric acid. By the way, this is H2SO4. And it is 18 molar, so we know 18 moles of H2SO4 per liter of solution, and then we've got the density. So we need to somehow find moles of solute, which is sulfuric acid. We actually already have that with the molarity. So this is our moles of solute, 18 moles there. But we need to go from that information to kilograms of the solvent. So if we find the kilograms of the solution, that's made up of the mass of the solute and the solvent. So we'll have to find kilograms of solute, kilograms of solution, and then be able to find kilograms of solvent. So we can find kilograms of solute by using the 18 moles of H2SO4. Then we can convert to grams using the molar mass of H2SO4. That's 98.079 grams per mole. And then because we'll end up using kilograms, I'm just going to go ahead and convert mass of H2SO4 in grams to kilograms. This is one of those unit conversions where you could do it now, you could do it later. So if it makes sense for you to do it later, that is fine. But if you do convert now, you should get 1.77 kilograms of H2SO4 in 1 liter of solution. So we have the amount in 1 liter, we have the mass of H2SO4. We're going to end up using the density to find the mass of the whole solution, because the 1.83 kilograms per liter, that's the density of the solution. If we have 1 liter of solution, we can find the mass by using the density. So when you see density in a question, I want you to think of it as a conversion between volume and mass. Because its units include some sort of mass unit and some volume unit, we can use it as a conversion. So again, we need to find kilograms of the solvent. We have kilograms of the solute. Let's remember that kilograms of the solution, everything together, is kilograms of the solute plus kilograms of the solvent. We found kilograms of the solute, that's the 1.77 grams of H2SO4. kilograms of solution we can find using the 1 liter volume and the density. So we'll say we have 1 liter and it's 1.83 kilograms per liter. So this is 1.83 kilograms. That's the mass of the solution. So now going back to this equation, kilograms of the solution, 1.83 equals kilograms of the solute, that's 1.77, plus kilograms of the solvent, that's what we're looking for. Let me use some highlight to make this a little bit more obvious. So kilograms of the solute, that's the 1.77, that's what we calculated up here. Kilograms of solution, that's the 1.83 that we calculated right here. So 1.83. Kilograms of solvent is what we're looking for. If we subtract 1.77 from both sides of the equation, we will get 0.0646. That's what I have in my notes. I must have kept some extra sig figs. This is kilograms of the solvent. So here we've calculated kilograms of solvent. So now to find molality, which is again mole solute, moles of H2SO4 divided by kilograms of solvent. This is 18 moles of H2SO4 divided by kilograms of solvent, 0.0646 kilograms. This is 279 molar. So that is the concentration, 18 molar 279 molal. 18 molar solution is 279 molal for sulfuric acid. One thing that I glossed over is that we kept the volume at 1 liter. That helped us calculate kilograms of solution in this part of the calculation. Again, it's a convenience just to define the total volume as 1 liter. That way we can calculate the mass pretty easily. Okay, so that's our molal. Now we need to do mole fraction. And let's remember mole fraction. I added another page because this is a little long. This is capital X. This is moles of the solute, which we've already determined is 18 moles, divided by total moles of the solution. So this would be moles of H2SO4, total moles will be moles of H2SO4 plus moles of the solvent, H2O. Now I recognize as we're working through it that the question didn't state that it's an aqueous solution or that the solvent is water. I will be more careful with that on any assessment, but most of the time when we're talking about acid solutions, it is in water as the solvent. But again, it will not be ambiguous if we're not working through it together. Okay, so we need to find moles of H2O. We already have moles of H2SO4 from previous slide, Moles of H2O, well, we have the mass of H2O. We can just do a molar mass conversion. We have 0.0646 kilograms of water. Let's convert kilograms to grams and then grams to mole. All right, so if you calculate this, you should get 3.5837 moles of H2O. So going back to our mole fraction, this will be 18 moles divided by 18 plus 3.5837 moles. And so mole fraction is 0.83. So molality right here, mole fraction right there. Again, just using provided information and the definition. We need to know to solve this question what mole fraction is and what molality is and molarity. Then we're able to use all the provided information to solve. All right, thanks everyone.